Hello, welcome to this first video on basic EIGRP configuration. The topics we'll be discussing in this video are aimed at those students that will be attempting the CCNA 2 qualification. Whether you're taking the full CCNA exam or taking ICND and ICND2, a basic understanding of EIGRP configuration is vital. In the second video in this series, we will be looking at EIGRP troubleshooting. You will be expected to troubleshoot basic EIGRP configurations on either the ICND1 or ICND2 exams, as well as the full CCNA. I will be using GNS3 to emulate several routers and perform my configuration. And here on the screen you can see that I've already added 4 routers to my GNS3 topology. We can see their names, R1 through R4. We can see interface labels and also IP information for the various networks that we have connected. I've already configured interfaces on all these routers with valid IP addresses, but I have not configured any EIGRP configuration. The goal at the end of this video then is to make sure that the routing tables on all 4 routers are complete with all known networks. So on router 4, I should see an EIGRP network for the 172.16.1 network from router 1. And on router 1's routing table, I should see a network, an EIGRP learn network for R4's network 131.107.0.0. So begin by configuring router 1 and then move on to configure routers 2, 3 and 4 with EIGRP. I've already got the consoles open, so if I navigate to router 1 console, and we'll use a couple of show commands to have a look at router 1's current configuration. So if we do show IP interface brief, so we can see 3 configured interfaces: interface fast ethernet 00, 01, as well as a loopback interface. All these interfaces are up and all have been configured with an IP address. If I show IP route, here we can see router 1's routing table with the 3 directly connected networks. So all as we would expect for a router that's been taken out of the box, been assigned a host name, and whose network interfaces cards have been configured. We now need to configure the EIGRP protocol on router 1 so that it can swap dynamic route information with neighbouring devices. So we start off by going to global config, and from global config we enable the EIGRP protocol. With a command router EIGRP, then a number. Now in my case, I'm using the number 1. This number is the autonomous system number. EIGRP is a hybrid protocol or an advanced distance vector protocol. This means that EIGRP has characteristics of both distance vector and link state protocols. Like link state protocols such as OSPF, 2 EIGRP routers need to form a neighbour relationship if they're to swap routing information. And just like a link state protocol, 2 EIGRP routers that form a neighbour relationship will swap topology information and then use that topology information to build their routing tables. Now for EIGRP, routers must have certain things in common in order to form a neighbour relationship. Firstly, they must be on the same network. So we need to use primary network addresses, we can't use secondary network addresses, and they will use these primary network addresses to swap hello packets. The second thing that we will need is to make sure that the interfaces are configured for EIGRP. So if I've got 5 interfaces in my router, I might want to configure 3 of them for the EIGRP protocol, and it's on these interfaces that hello packets will be sent out of. Also, in order to form a neighbour relationship, if we configure EIGRP authentication, then the authentication must match on both sides of the connection. Also for EIGRP, if we want to form a neighbour relationship, K values must match. K values represent the weighting given to the different metrics that EIGRP use. And finally, for EIGRP, if we want two EIGRP routers to form neighbour relationships, then the autonomous system number must match as well. So with this command router EIGRP1, we're identifying the autonomous system for EIGRP as being autonomous system 1. I will then use the same autonomous system number on each EIGRP router I configure. So to recap, in order to form neighbour relationships, the two EIGRP routers must be on the same network. EIGRP must be configured on the interface. EIGRP authentication must match if we're using it. EIGRP K values must match. And the two EIGRP routers must be using the same autonomous system number. Now, to enable EIGRP on our interfaces, we use network statements. So from beneath the EIGRP process, I type in network and a network address. Now, if we just scroll up, you'll see that I'm connected to the 10, the 11, and the 172.16 networks. And I want to enable EIGRP on for all of these networks. So I include the network statements. Now, it's important to understand what these network statements are doing. When I type in a network statement like network 10 and hit return, we are not saying advertise network 10. What we're telling our router to do is in fact go look at any of our network interfaces that match the Class A network of network 10 and configure EIGRP on those interfaces. As a byproduct of that, also advertise the networks associated with that interface. So, for example, if I type in network 11 and hit return, then EIGRP will be configured on any interface that matches the Class A 11 network. If I was typing network 15, well, none of my interfaces are on the 15 network, so this network statement is wrong. We only configure network statements for directly connected networks. Now I've configured EIGRP for network 1011. We don't need the 15 statement, but I'm also going to configure it for my loopback interface of 172.16.0.0. Now, EIGRP supports the use of wildcard masks. So as well as adding classful addressing in this way, we can also add wildcard masks to our network statements. These wildcard masks allow us to be more specific about which interfaces EIGRP is enabled on. For example, if you had these three networks, how many EIGRP network statements would we need? Well, the answer is 1. I could use this network statement and it would advertise all 3 networks, or to be more precise, it would configure EIGRP on any interface that matches any of these network statements. But if I wanted to enable EIGRP on a single interface, I could use this statement. And by using the more specific wildcard mask, EIGRP would only be configured on our third network there. So although the wildcard masks are not required as part of the network statements, they can be used to limit the interfaces the EIGRP is configured on. Now router 1 here is now fully configured. It has EIGRP with an autonomous system number of 1, and I've configured 3 network statements to match my 3 directly connected networks. With router 1 configured for EIGRP, we can now take a look at configuring routers 2, 3 and 4. We'll do router 2 first, and what we'll find is that as soon as I configure router 2's interfaces for EIGRP, I'll have 2 routers, router 1 and router 2, that will be able to swap hello packets. And because we've not played around with any of the default criteria, they should be able to form a neighbour relationship with each other. And we should see that neighbour relationship come almost straight away. In the later video, we'll be looking at verifying the neighbour relationship and troubleshooting the EIGRP relationship as well. Right now, we just want to get EIGRP configured on our 4 routers. So if I flip to router 2, and we'll start our configuration of router 2. So if I do show IP route, we can see the directly connected networks for router 2. And then from global config, router EIGRP1. Again, making sure now that the autonomous system number matches the autonomous system number used on router 1. And then 2 network statements for network 10 and network 12. Now you see almost straight away, as I've configured EIGRP on network 10, and again, just to remind you, when I've added the network 10 statement, EIGRP has gone off on this router, it's found interfaces that are on the 10 network, it's enabled EIGRP on those interfaces, it's then been able to both send and receive EIGRP hello packets on those interfaces, and it's seen the hello packets from neighbour 1, router 1. It will have assessed the criteria for the neighbour relationship, make sure all matching criteria matches, and then it's formed that neighbour relationship. This router 2 is also sending hello packets now out of the 12 interface, but because there's no other router configured on that interface, no neighbour relationships come up. If we go back to privilege exec, and we run a show command, show IP EIGRP neighbours. Show IP EIGRP neighbours. We can see the neighbour relationship with my neighbouring device. So router 2 is configured. I will quickly now go through and configure router 3 and router 4. Excellent. So router 3 and router 4 configured. On router 4 here, we can see based on the show IP route command, I've got 2 direct connected interfaces, and I've configured, using my network statements, I've configured EIGRP on both those interfaces. If we remember our diagram and just take a look back at our diagram, we'll see that network 4 is also supposed to be connected to this 131.107 network. So what we'll do is on router 4, add a network statement for the 131.107 network as well. But if again we look at our routing table, we will see, although we can see EIGRP load routes now, there is no 131.107 directly connected network. There is no 131.107 interface. So although EIGRP has a network statement that would enable EIGRP on any interface on the 131.107 network, it's superfluous to our configuration right now because I've not configured that loopback interface. If we do show IP protocols, show IP protocols shows me my EIGRP configuration, including K values. We can see the EIGRP autonomous system number. And we can also see that we are routing for and then a list of networks. So that 131.107 statement stays in our EIGRP configuration. It's just not going to advertise that network because there's no interface yet that matches that address. So what we're going to do is quickly configure an interface loopback 0 and add an IP address on the 131.107 network. And yep, that network is using 16. Now I have that interface configured, we go back to show IP protocols, and because that configuration is already in there, we don't have to type the network statement again. But you can see now, if you look under the section that says automatic address summarization, if we scroll up to our previous show IP protocols, it only listed networks 12 and 13. That's because they were the only networks with configured interfaces, or rather I had interfaces configured in those networks. But now, after I've added a loopback interface, we can see 131.107 network is added as well. So all 4 routers are now configured. If I do show IP route on router 4, we can see 3 directly connected networks and 2 networks learnt through EIGRP. If we go to router 1, show IP route to see our IP routing table, and there we can see the 3 EIGRP learned networks. So all of this is looking good for basic configuration of EIGRP. Quick question, based on my configuration, how many neighbours should router 1 have? The answer is 2. EIGRP forms neighbour relationships between directly connected network neighbours only, or directly connected devices. So router 1 is neighbours with both router 2 and router 3, but not router 4. Both router 2 and router 3 are passing through router 4's information towards router 1. So they are neighbours with router 4. They see router 4's topology updates, then they pass those updates on to router 1. But EIGRP routers will only ever be neighbours with their directly connected neighbours. If we go back to router 1, you can again see an example of this. If we take a look at the 131.107 network in our routing table, notice there are 2 paths through which we can get to network 131.107, one via router 2 and one via router 3. Next question, what are the 2 numbers in brackets? The answer, the first number, 90, is EIGRP's internal administrative distance. The second number is EIGRP's metric. EIGRP uses a composite metric based on bandwidth and delay, and this is the metric used to get to network 131.107. Because both of our neighbours are advertising a path to 131.107 with the same metric, both are added to the routing table, and my router will load balance traffic across both connections. So in this video, we have configured 4 routers with EIGRP. We've used show commands, show IP protocols, show IP EIGRP neighbours to view our EIGRP configuration and to verify that our neighbour relationships are up. In a later video, we will then take a look at EIGRP troubleshooting. Thank you.